introduced Chiprack, the new award-winning approach to the assembly and disassembly of electronic components. Traditionally, computer systems have been assembled onto one or more printed circuit boards, usually called PCBs. The function of the PCB has been to connect the electronic components together, as well as to provide a mechanical structure for supporting them. Many modern computer systems consist of a number of these PCBs, which are connected together by a rack into which the PCBs are fitted. The rack provides the interconnection and mechanical support between the PCBs. A variation on the same racking theme is provided by the personal computer, or PC, found in many offices and laboratories. Here, a central PCB, called a motherboard, has a series of expansion connectors into which can be plugged a number of smaller PCBs, holding additional computer subsystems, such as video controllers, disk controllers, and network interface cards. Recent advances in silicon technology have reduced the whole of the circuitry of some of these PCBs to single large-scale silicon chips. The electronics on this PC motherboard, for example, have effectively been incorporated into this single silicon chip. In the same way, the electronics on this graphics expansion card are now available as this single component. What has happened is that many individual components have been integrated into single large silicon chips, together with most of the interconnections between them. Traditionally, PCBs have been slotted into racks. Now these PCBs have been turned into large silicon chips. What could be simpler than to use a miniature rack designed to mechanically support and interconnect them? That's Chiprack. Current assembly methods for PCBs involve the sequential placement of components, one at a time, over the variable geography of the PCB. The automated process therefore needs expensive, complex software-controlled machines to sequentially pick and place each individual component. While these machines pick components and place them sequentially, it's actually always been possible to insert a number of PCBs simultaneously into a PCB racking system, quite simply by pushing them all in at the same time. The Chiprack approach makes it possible to interconnect large silicon chips simultaneously too. All the chips can be placed in one simultaneous action, then mechanically supported and interconnected by a simple compression of the Chiprack. The Chiprack connectors lock together while holding all the parts in positive registration during the assembly process. Automatic assembly of Chiprack systems can be done by simple, low-cost, hard-tooled machines. Much faster automated assembly at a fraction of the cost. If we return to our earlier example of the PC, it's now possible to see the Chiprack approach to building industry-standard PC systems. One PC motherboard on a single chip. One hard disk controller, one floppy disk controller, parallel port, two serial ports, again, all on a single chip. One service carrier holding the clocks and reset circuitry, all available as a single component. One video block. Some blocks of memory. One compression, and the result is a working PC system. Add some more memory, change the processor, add a new video controller, change the disk controller, rapidly disassemble into reusable components at the end of the product's life. Chiprack's versatile connectivity means this PC in a tiny stack can be quickly and easily tailored into a wide range of products. Instruments, data loggers, entertainment products, industrial controllers, camera systems, point-of-sale terminals, vending machines, medical equipment. Not only can you quickly reassign components within the stack, the unique characteristics of Chiprack enable signals to be rerouted at the intersection of each block of electronics. It's no wonder that when EDN magazine identified Chiprack as one of its Hot 100 products, it chose to describe it as implementing a reroutable backplane. Chiprack is your route to lower costs, rapid, flexible, snap-together assembly and disassembly, modular design, test, upgrade and repair, software reconfigurable hardware, innovative three-dimensional architectures, and new, compact, robust products. Chiprack, it's the next logical step forward in hardware development.